Thanks for coming out, folks. My name is Zackory. I'm an environmental quality specialist for Coconino County, and Valle is my area of inspection. So I am out here pretty much every day of the week almost. So you guys are keeping me busy out here. So I'm gonna go over kind of just a brief overview of on-site wastewater systems. What the heck are they? Why do we need them? Things like that. And then I'm gonna break down into a little bit more slightly technical stuff, starting with site investigations, what we're looking at, why we need test holes dug, everything like that. And then we're gonna go into kind of a short synopsis on permitting and the process of permitting and how we permit wastewater systems, why the typical systems, what we see out here, the reasoning behind those and everything. So I'm just gonna start off real quick with just some basic overview here. So like I said, we're gonna talk about permitting first, then I'm gonna drop into site investigations, and then for Valle, why are the majority of the systems alternate wastewater systems? What are the reasonings behind that? And then I'm gonna break down some common questions, including gray water, composting toilets, and then vault and haul systems. So we'll get a little brief synopsis on each one of those as well here towards the end of the presentation. So, all right, wastewater systems. I just kind of got a brief overview. If folks aren't really familiar with what wastewater systems are, it's not just a septic tank in the ground. There's also a disposal field component as well. So what happens in the tank, it leaves the house, and this is where your separation happens. There's actually some slight treatment that goes on in that tank as well. And there is layers that are developed with the bacteria that happen to break down in the wastewater system. So then what goes out to your disposal field or your leach field is going to be septic tank effluent. So it's a treated wastewater with household regulations that we are permitting off of. So just a brief overview, chamber system, what we kind of typically see out here. We also still can use gravel, like rock and pipe as well. I included this one because typically what we see out here are more alternate wastewater systems, and the number one being an aerobic treatment unit, meaning that we're pumping oxygen into a chamber in that tank, and that's gonna be a secondary treatment before it goes into chlorination, which would be your tertiary treatment, and then out to your disposal field for your final disposal and uptake with the native bacteria taking care of the rest of that wastewater in there. So just a brief overview of what systems are. So we are delegated, all the 15 counties in Arizona are delegated through the Arizona Department of Environmental Quality, ADEQ. Our permitting comes from this right here. This is the Aquifer Protection Permit Program, Title 18, Chapter 9, Section 3, to be specific on where all of our wastewater comes from. So the Arizona Administrative Code is where that all comes from. And just like I said right here, this is where all the rules and regulations are. Now this is a 24-year-old rule that we are dealing with right now. And like I said before, we don't have the final say as Coconino County. Everything has gone through the state all the way up to the governor's office is where this actually comes from. We have a two-part permit system. This is not including the site investigation. That is going to be kind of a third party, our third permit for that as well. But to permit, what we issue for construction is called the construction authorization. That gives you guys the go-ahead to put it in the ground, meaning that it met all the minimum qualifications per our rule. And then that's when I come out and do the final inspection after that's in the ground. And I make sure that all those components that we reviewed during the permitting process are installed in the ground and everything's going to be functioning. And then the last permit that's issued is the discharge authorization, or short, the DA. That means you are good to flush a toilet once you have that hooked up to your residence. And then kind of just a breakdown here, of what we're doing here. This is the Aquifer Protection Permit. I know water is very deep in this area, but the idea is still the same. Like when you put water through your system, it eventually, potentially makes its way back to the aquifer and recharges that. So it's just kind of a little breakdown of what we're trying to keep out of our groundwater, which is our drinking water. Okay, this is kind of small, so I do apologize, but this flow chart is from the county website, and this is the permitting process. So like I said, and we'll get into it here on the next few slides, is the site investigation process. That's where we're going to come out. We're going to do a soil characterization of those test holes that have been dug. We're also going to look at any of the limiting conditions that are surface as well. Are we dealing with drainages? Are we dealing with rock outcrops? Things like that that we're going to have to meet setbacks and adjust on there. So number one thing is our site investigation. That's where we're going to get our soils information from and everything that you're going to use to design that wastewater system to overcome those limiting conditions. So then after the site investigation report goes out, it's going to be in the design phase, and that's back, with you folks. If you decide to go with a designer, or if you guys want to design it yourselves, this is the process here. And then you're going to apply for the septic permit. It's going to go through a review process, and we're going to determine if it is good. We're going to go ahead and push it through, and we're going to, make sure, like I said, it's going to meet all those minimums. Requirements that are under whatever rule that you're applying under. A lot of times it doesn't work out the right way, so we're going to send it back out for corrections. That goes back out to you folks or the designers. They're going to make those corrections and they're going to submit it back. We do, in Coconino County, we'll do 3 reviews and then we make a licensing decision. If we can't get all those corrections done within 3 reviews, we're going to deny the permit. And that means you're going to have to apply over again if it doesn't go that way. A lot of times we still work with people that are like just right there at the finish line. They just needed a few things. So, this is the area right here where all those questions can be answered. Call us up on the phones, talk to us, come into the office. We're there to work with you. We want to make sure that this wastewater system that you guys are putting your good hard-earned money into is going to function for that life expectancy of the wastewater system. So like I said before, once it goes through a review process, we're going to issue the construction authorization. It's going to go, and a contractor, you folks in the state of Arizona, can install and everything just as well as the design. So it will be in that phase, and once it's popped in the ground before you cover it is when I come back out. And I'll make sure, like I said before, all those minimum requirements are met, setbacks are met, etc. So we'll do the construction. I'll come out for the final inspection. Majority of the time, it's a pretty good smaller system out here because we do that hauled water credit for you and everything, so we can reduce that footprint of their disposal field. So we don't typically have giant wastewater systems like we see closer to Flagstaff. And so this is the final inspection area. Like I said before, 2 permit process. Once it's approved, I get our final documentation which is mostly an as-built drawing, which is 97% of the time what's issued on that construction authorization plan set. Something happens in the field where we got to tweak something. And so what's required is an as-built drawing. And typically we like to see those before we come out to the final inspection, so that way we know where we're looking at instead of bringing out the corrections. But I always go kind of old school. I draw out the system and everything. That way there's a reference that I attach to your guys' permit from what I saw out there. So we can reference what was approved, what I saw, and then what we can work with to get that as-built drawing submitted and everything as well. So once I get all that, the request for discharge authorization and the as-built. What the request for discharge authorization is just a form giving me, again, your guys' contact information. If you guys had a designer or if you had a contractor, all their information's there. If you put a contractor down on that request for discharge authorization, they do have to be a licensed contractor. They have to have a license either through septic, or they can be just a general like B class, like plumber and things as that as well. We just want to make sure that if you're putting a contractor down that they are a licensed contractor. Once I get that, the DEA is issued. So again, you're good to flush is what the operate means. So once your house is there, you guys got your wastewater system, everything's good. I'll close the permit out. I'll sign off on the building side as well if we're going that route. Everything's done. We're good to flush, and you're good to use the system. Okay, so this is my favorite part of the job, site investigations. Again, I apologize for the small print here, but what we're looking at is, a minimum of 3 test holes that are dug, majority of the time with a backhoe. I like to see at least a 3-foot bucket. 2-foot bucket works as well. We just don't like those 1-foot buckets because I need to see the sidewall of that test hole. And the smaller it is, the harder it is for me to get in and test that out. And so 3 test holes are required. Nina? You can hand dig a hole if you want to take a shovel out here. And I've seen them a few times out here. I've seen them a lot down in like the Sedona area, just because the soil's so shallow, you're going to hit bedrock within maybe a foot. So you can do a hand dug site investigation as well. I would prefer if you tell me that, so that way I know what to look for, because usually I'll look for those spoils piles when I'm driving through, and so hand dug usually a lot smaller, but I have seen quite a few hand dug ones out here as well. So that is an option for you, that you don't need to go and get a backhoe. Yes, sir. Mm-hmm. It does. So when those Wisconsin mounds are built, meaning what you're typically seeing them in Baderville and everything, Fort Valley, that water table is so high, it's at surface. So there's no usable soil for you to discharge into, so you got to build it up top. You still need to dig down the hole. We need to see where that that groundwater's at and whatever other soil conditions are at, because you're still going to design those type of systems based off the interface of where the sand meets native soil. So we need to see that. Yeah, exactly. So that's getting into systems, but we'll get back to site investigations. 3 test holes are minimum. So you're going to want to have 2 in a primary area where you folks want that disposal field to be placed. So this testing is just for the leach field and the disposal field placement. Your tank you could put anywhere. You could jackhammer through pure rock and pop a tank in there if you wanted to. But what we're looking for is the soil characterization, and we're looking for native soil. So that's why we need those in the area where you're going to be discharging into with that leach field. So you can dig up to 8 test holes with our permits. So a lot of people will do, especially on the larger parcels, do 4 in one section and 4 in another section. That way they kind of have variability of where they want to place that system. You always want to keep in mind you want gravity on your side. Things flow downhill. So, but it's totally up to you on where the placements are and things like that of those test holes. And what I typically tell people when they're like, how far apart? What we consider tested soil is a 30-foot radius surrounding that test hole. So I like to see them about 50 to 60 feet apart. That way you can spread out, consider tested soil, and then you can put that placement, because the primary area requires the 2 test holes. That's where you're going to put your disposal field. That 3rd test hole is for a reserve. So if you have an expansion idea, down the line, you already have tested soil, you don't have to go through the site investigation process again. If it's typically, most of the time they do them in a triangle pattern, all 50 feet apart, 2 in a primary, 1 in that reserve area. So that's why it's at least a minimum of 3 test holes, but because we want it in what we consider like mostly undisturbed soil, even though there's those 2 test holes there in the middle, majority of it's still going to be undisturbed. So you don't dig a bunch. So when people call up, or I'm out in the field and people are asking like, how deep do I go? It's until you hit refusal. So once your backhoe or your shovel hits bedrock, that's what we're going to consider refusal. Just stop digging. There's no need to either break a shovel or beat up that backhoe. Just stop digging, because what we're looking for is soil again. I'm signing a soil absorption rate, so when it's rock, I can't do anything with it. That's going to be a limiting layer. I did this site investigation last week, just down the road right here. Typical site investigation test hole that I see in the area, so I'm going to kind of walk you through the process of what I see. So this is just from above. Again, you can't really tell, but it's not that deep. This one was like 42 inches in total depth. But here, this is what you're talking about as well. They dug about 2 feet through this bedrock right here, where they didn't really need to dig that deep. Like, this is massive, just limestone is what it is. So you can really see where it's soil, and then where it ends right here is a pretty abrupt horizon or differential between rock and soil. So I also did, I don't know if you guys want to pass it around, but I brought the samples from this site as well too, if you want to see it. So yes, right here. It's high in calcium carbonate. What's that, sorry? What it typically is out here is like the Kaibab, sandstone, and then you get into some of the limestone as well. Yeah, it's what it would be in. Whatever we classify it as, I classified it as, just a bedrock, because I'm not a soil scientist by any matter. I'm just calling out what I see, because what we're getting into is these depths right here. Yeah, but the thing is, what I'm saying is that volcanic ash, more about percolation. Mm-hmm. Exactly.
But they obviously hit the hard layer.
Yeah.
Bottom, which then third over is.
That's why I have this little slide right here, is because this layer here of volcanic ash is going to have a bunch of cracks and crevices and so we don't know where the wastewater is going to go once it gets into that. A lot of times what happens is it hits one of these cracks and it's going to take the path of least resistance and end up on a cut bank on your neighbor's property. So that's what we're looking for, and that's what the main thing out here in Valle is the shallow soil above bedrock. And we don't want to discharge into the bedrock or be too close. We want to make sure that the wastewater is absorbed up here and then treated up here, because there is, native bacteria that's going to clean that rest of that wastewater out before it does hit this. And then if it does pop out your neighbor's, cut bank, it's going to be cleaner wastewater than if you're just dumping it into a hole. So that's what we're looking for out here in these site investigations is, no matter what the classification of this is down here, it's a limiting layer that you're going to have to make sure that you meet the correct separation before it gets to that area, just so we don't have nasty water popping out somewhere that we don't know what's going to happen. I mean, it could hit this and go all the way down to the aquifer, but again, we don't really know. This is where that minimum vertical separation comes into play. So I thought that was kind of a good little schematic of like our main concern of when it hits wastewater or hits bedrock. Oh yes. So no matter what, I'm always taking a max depth of a test hole. And then, so when I'm standing up top, I'm going to take a total depth of this test hole. I'm going to indicate it on the sheet. And then I'm going to start breaking down those soil horizons, starting from the top, and I work my way down. So this one's pretty simple. I mean, when you're looking at this top soil horizon here, there's no real change in coloration or structure, things like that. It's safe to say that I have one soil horizon right here. And so what I'll do is I'll take my rock hammer and I'll use a sieve and I'll sieve it through a number 10 sieve. This is all an ASTM standard, so an engineer created this, and there's a giant equation that goes into the soil absorption rate. But what we do is a texture by feel. And so I'm going to take a sample and I'm going to get it through that sieve. I'm going to get that sample wet in my hand in a moist consistency, kind of like how Play-Doh felt like as a kid. And I'm going to take that sample, I'm going to run a ribbon using my pointer finger and my thumb. And when that ribbon breaks by gravity, I'll take a measurement of that broken piece of the ribbon. And the length of that ribbon is going to determine where it falls in that kind of soil triangle. Are we dealing, obviously when it's a ribbon, you're not dealing with sand because that's not going to even form a ball. But what we're dealing with mostly is a loamy material out here. And that's what's nice is the soil is really nice soil out here. You just don't have a lot of it. It tends to be more a silty loam or a sandy loam. And then in certain pockets out here in Valle, you can get a little bit more clay content, but not much to where you're dealing with pure clay. So I'll work my way down this here for multiple horizons. I'm taking depths as well. And then this is all going to go into your soil site investigation report. And so again, I kind of zoomed in on here. You can see the structure difference of what the soil is here and here what that bedrock is. Like this one was pretty massive and unique, where a lot of the times you see a lot of platy material and a lot of fractures and things like that. So it could be a little bit easier to dig through than when you have a little bit more just a solid mass. But I just wanted to kind of show you guys, like you can see some rocks starting to show up here, but a majority of soil, and then you can see that interchange right there, and then it's pure bedrock. So again, those are those samples that are passing around of what I took. And I usually just, kind of indicate the difference between, what it is. I have a hydrochloric acid solution, so I drop it on there. If it bubbles, I know there's calcium carbonate buildup in there, and it just helps me on my report. And then, if people ever have any questions, it breaks it down a little bit easier. But so I'll indicate soil, structure, type, everything like that, rock percentage in there. It goes into that chart. And then at the very end, I'm going to assign a soil absorption rate based off that ribbon length. And then that's what you're going to use. That's a soil absorption rate to design the system based off the size of the residence. And so again, that's just kind of how I broke it down. This is that chart I was telling you about right here. So I'm going to have this little schematic up top with total depths, and I'm going to break down each horizon like I did here with depths. and then I'm going to texture it. I'm going to say what the structure is. I'm going to look at rock percentages. Out here, we're not really worried about modeling, and what this term of modeling means, it's a redox reaction, meaning that that water is held on by that soil. We don't really have to deal with it out here. We deal with it a lot more closer to Flagstaff and things like that. And then everything's going to be moist consistency. So if I could break a PED when I get that wet, which is pinching it, it's going to be a friable, wet, moist soil that I can assign a soil absorption rate. If I got to squeeze it, or if I have to drop my boot heel on it, it's going to be more of a site-specific soil, or what we consider massive, or like a super strong structure. And that's meaning that it's compacted.
So what I'm gathering is you're gathering information so that you can help us design a system that works for
This specific site, yeah. So everything's site-specific. So, even though majority of the parcels out here have similar conditions, each one's going to be varied a little bit different. Like they can be super shallow test holes, or it could be super deep before you start hitting those bedrocks. And I'll get to why conventional systems aren't really in this area, which is right here. So think back to that, two horizons on that picture that I showed you, where you had the soil down to 36 inches, and then you had that rock down to 55. So what we need for conventional disposal is 48 inches of native soil underneath your disposal works. So if you put chambers or your rock and pipe, you still need 48 inches of soil below that in order to go for a conventional type system. And so like out here, we're not getting that much soil. So we have to pre-treat that, which allows you to shrink that 48 inches down to a lot of times 6 inches before you hit a limiting layer. So that's our main reason on why we don't see conventionals out here. Yes, sir.
So one worry
Mm-hmm. Mm-hmm. It's understandable.
So then if you're limited on depth of filtration capture, have a way that do it without having to put chemicals.
So unfortunately, no. And again, it goes back to that rule. We're dealing with an old rule, and there is a UV disinfection that you can use, but again, that gets more costs. It gets more pricey. Those UV bulbs do last about 15 years, but again, it depends on the use and the abuse of the system. If you're flooding it with a lot of solids, that bulb's going to burn out a lot faster than if you're really, easing that wastewater system with just, clean effluent that's going out in there. So a lot of times, those are the two treatment types that we are permitted under in the state of Arizona right now, is your chlorination, or you're going to use a UV bulb to disinfect that wastewater. Because it goes through a chamber system inside that tank again, and in order to get that separation and the reduction of that, it does have to have that chlorination or UV.
Does chlorination affect microbes?
No, no. It's a 70% chlorine, so it's not as strong as like pool chlorine. It is a specific tab that you're going to use for wastewater systems, and the calculation that we review on there is to ensure that what's going out to native soil for discharge is not going to have a bunch of free chlorine going out there, because if it, like you just said, if it did have a lot of free chlorine, it's going to affect that native biota in the soil, and that's not what we want. We want it. It's a low chlorine content that's going to treat inside that. So it has a contact time that we're going to calculate out during the plan review. And so then when that water passes through that contact chamber, it's going to be clean, chlorine-free effluent that's going out to your disposal field. I think it's chlorine hypochlorite, but it's like a 70% reduction on that. I could get you it. It's in my book. Yeah, there's two types that you can use that you do not disinfect. Anything that you're using sand, they don't want that chlorine going in. So it's yeah, no, that's fine. That's what we're here for. So if you use the mounds, they don't want chlorine going out there. And then if you want to use like a sand line trench, so some Elgin systems, Elgin pads, those aren't going to use chlorine either. So there's two types. Elgin Brands, Eljen. All right. So that was kind of just a brief synopsis of what we're seeing typically on why Valle is going more alternate wastewater systems than conventional. We just don't have the amount of soil that's going to be required by that rule in order to do a conventional wastewater disposal. So we're going to get into gray water first, and then we'll get into a few of the other common questions that I get from a lot of folks out here. So gray water is allowed in Arizona, and these tiny little words right here are the 13 regulations that you need to meet. Our main ones that we're looking for is that it's going to stay on your property. It's used for irrigation purposes for non-edible plants unless you're using citrus or fruit, or citrus or nuts. Just because, again, gray water is coming from everything but the kitchen sink and your toilet. So, you do have that potential for pathogen buildup if it's going to be going into a holding tank or if it's going to be surface discharged. You want to make sure that, you're not in contact with it as much because, again, it is an untreated wastewater just coming from a little bit more diluted, areas of the house. So black water is your toilet, and it's going to be the kitchen sink as well. In Arizona, they considered kitchen sink black water just because of that potential for pathogens. Cooking and washing your hands with raw chicken and everything like that. They didn't want that to go out to your irrigation as well. Gray water also, though, needs to be diverted back in to your wastewater system for the non-watering months. So when you're dealing with winter and snowpacks and stuff like that, you're not going to be overwatering your plants. So it needs somewhere to go. So you do have a diverter valve that goes back into your wastewater system for those areas of non-watering. So, but like last winter, we didn't have much, so you could have watered all year long. So, but again, it's just for that, so that way your wastewater is somewhere to go when you're not watering. So again, this is kind of just a brief synopsis of what the gray water is and everything like that. So everything but the kitchen sink and your toilet. Composting toilets are another major question I get for this area. It is a permit. We can permit composting toilets. It is an alternate wastewater permit because, again, you're still dealing with the black water coming from the kitchen sink. So you have a smaller footprint on your entire wastewater system. You can decrease the disposal field and the tankage by 40%. So you have a lot smaller footprint because, again, it's just that water going out from the kitchen sink. Everything else is going to be going through that compost toilet. And then when you go through that permitting, though, again, ADEQ, Arizona Department of Environmental Quality, only has these that are approved. So there is 1, 2, 3, 4, 5 companies that are used or that are approved through the proprietary product listing that I'm allowed to review. So there's not that many options, and some of these options are quite pricey, like $6,000 for a toilet. I'm not too sure on the prices, but the one I see mostly is this Sunmar Corporation. That's the one that I've seen. I've only seen a few permits actually come through my desk for composting toilets, but hopefully there's things down the road. Things will be able to get a little bit easier on that. But again, it is an alternate wastewater permit. It's only these companies that we're allowed to review. And then again, it does have a tank and a smaller footprint on that disposal field for the black water. So again, it is something, this is just a little schematic breaking down bedrooms here. And then, so if you went through a conventional, tank, the smallest size is 1,000 gallons for just, either an alternate permit or conventional. When you reduce it down by 40, a 3-bedroom house, you can have a 270-gallon tank. So it does reduce that footprint down quite a bit, but there still is that disposal field and tankage requirement for this under this permit. So, all right, the last one is vault and haul systems. So that's just tanks that are going to be put in the ground. So per the Aquifer Protection Permit Program, this is the very last case scenario. And the reasoning why is it is expensive. The idea is, you have tanks, it's going to be cheap up front. but it's that 20-year life expectancy of your pumping costs that are going to be like a second mortgage for you. So when you design these systems, the tankage needs to be 10 times your design flow. So your design flow is how many bedrooms, how many plumbing fixture units. So typically a bedroom, a house, 3-bedroom, like 2 baths, is going to be a 450 gallon per day design flow, which is 2 times what anybody's normally going to use. But these things are designed and permitted for those Super Bowl parties or a giant family reunion. So when everybody's at the house, that system does have the capacity to handle flows like that. Where most people are, using a family of 2 or 3 are going to be using anywhere like 250 gallons at max. And out here, you're on hauled water, so it's going to be even less because you're conserving water a lot more than when you're just hooked up to a main. So, for example, I was going to do a 300 gallon per day design flow system, which is going to require 3,000 gallons of tankage installed. And what it's going to cost, I called a couple pumping companies from Flagstaff that are servicing this area. On average, they were saying about 650 gallons per 1,000 gallons. So if you had 3,000 gallons, it's going to get costly. So 3,000 gallons. I just broke down what an average, city use water is for a family of 4. Most people use about 50 gallons of water per day that's going out to the system. So it takes typically a family of 4 only 15 days to fill up 3,000 gallons. So at minimum, you're going to be pumping twice a month if you're on a vault and haul system. And so I broke it down here. So to pump once, you're almost at $2,000 for this average of these companies that I called. So then if you're doing it 2 times a month, you're almost at $4,000 a month on pumping fees. And then again, per year, you're at $48,000. And that's just 1 year of pumping. So this is why these are last case scenarios. It's trying to save you folks cash when this money here that you're going to spend per year on pumping can be put into a system that's going to last you 20 years. So that is why they push away from those vault and haul systems, and it's a last case scenario. Because we don't want to say that a lot's undevelopable if we had to deal with just pure bedrock or something like that. This is one case scenario that you're going to have to go vault and haul. Or if you're dealing with like drainages and smaller lots, again, sometimes you're not meeting setbacks, you're going to be going with vault and haul. But again, the state tries to keep it away just because of how much it's going to cost you folks to get that service every year, or a couple times a month sometimes. Again, this is going to vary because of people that are on hauled water. You guys are going to be conserving a lot more because it's a job to get that water out to your property. But again, this is kind of just an average here. So that was the end of my presentation. So if we have any questions, Nina has
I just have
a
one
slide.
quick slide, but then if you want to stay up here,
Yep.
and then we can answer questions. I just wanted to let you all know about a project I'm working on. I've been doing this for a few years now, trying to come up with a affordable on-site system for particularly this area, just because we have had so many code compliance cases up here related to wastewater. So I applied for some technical assistance through EPA's Closing America's Wastewater Access Gap, and I'm receiving that technical assistance now. So we are working with the state, looking at options for what we could do here that wouldn't cost so much. So I'm not going to go into a lot of depth about it because I don't know if we are ever going to be successful with this. So we're trying to get approval from ADEQ for some concepts we have. And then, once we get that, we are going to be applying for funding to try to do a pilot program here. So I would love to use this opportunity to learn a bit more about water usage in your home, because we would like to design the system that we are, proposing to ADEQ in a way that accurately reflects what those systems will be serving. We know that this area is on hauled water, and so we know that there is less water being used here than, what the rule might expect. And so that's one thing. Because of the hauled water situation, we're wondering, like, are people, do they have washers in their home? Is that something we can expect and our system is going to need to accommodate? So I'm hoping you would take a moment to, I have paper copies of our little survey. It's just 10 questions, completely anonymous, but just to get a little more information about how many gallons per day you use. Do you have a washer in your home? That sort of thing. If you do use gray water for irrigating plants already, are there any particular plants that work really well that you've found? So if you wouldn't mind, we've got a QR code. You can take it. It's a Survey Monkey, completely anonymous, or I have paper copies. So yeah, that's about that. Just also letting you know we are really trying. We understand that systems are extremely expensive here, and we are trying to figure out a way to help.
Thank you for all your hard work.
Yeah, you're welcome.
And I brought my business cards too. So if, feel free to shoot me a text, give me a call. I'd be happy to answer any questions and things as well. We're getting into our busy season right now, so I'm at least doing 5 or 6 inspections a day. So I've been flying around. So leave me a voicemail. I'll get back to you as soon as I can on, a day that I can have a little bit more time to discuss your topics and everything as well. So.
And I can put my business cards out as well if you're interested in sort of sustainability, approaches. I like composting toilets, gray water, all that. I'm happy to talk to you about that too. And I actually have a wastewater system design background, so I can usually help with most wastewater questions as well. So yeah, we have a little bit more information. I should mention that right now the county is currently updating its comprehensive plan. And so this is an opportunity to weigh in about what you see the vision, how you see the vision of Coconino County. Right now, we've just gone into the 60-day public review. And so you can, what they would like you to do is to comment online. And we have a comprehensive plan up here you could look at, but I also have, again, a QR code for you to scan if you would like to get online onto Conveo and provide comments on that. All right, any questions before we wrap this up?
We could talk a little bit more about the alternate systems
Yeah, yeah. So
Okay.
typically what I see out here are what we call aerobic treatment units. So I can go back to that one slide and kind of just give.
Yeah, when you say it pumps oxygen in, is there actually an oxygen?
Yes. So instead of a common septic tank where you're going to have 2 chambers, this one's going to have 3 chambers. So your first chamber when it leaves the house is going to be your trash tank. That's where your separation of your solids and liquids are going to happen. Your effluent or your liquid's going to flow into this oxygen or this aeration chamber right here. So there's going to be a blower motor or there's a little agitator that's installed in there that does require electricity, but it's going to be on a timer and it's going to X amount of times through that day, it's going to pump O2 and it's going to rotate in there. And what that does is it changes the environment inside that tank from an anaerobic, where there's no oxygen, to an aerobic environment, where treatment's going to happen at a much faster rate. And it's not stinky. Yeah, when you open this tank, it should not smell. It should have a pretty earthy smell to it, not a bad smell. And so what that does is it's going to affect the treatment value of what those permits are. So when you have a conventional disposal and system, it's just that septic tank effluent or the wastewater going right out to the disposal field. And all of your treatment's taking place in the soil. So that's why in Arizona it's required that 48 inches of soil depth in order to maintain that.
You have to have 48 inches percolating soil ability.
Below where you install your septic field. Yeah, that's not included in that 48 inches. So your leach field and rock or your chambers or whatever you're going to use for your technology, that 48 inches is underneath that. So at minimum to get that, you need at least a 6-foot test hole of soil top to bottom, in which I've seen it twice out here in Valle. one way down south and then one way up north. So and that's again why everything is permitted site specific, because what your neighbor has doesn't really mean what you have. I've seen those test holes change within 5 feet of each other pretty much sometimes. 100% different composition of soil. Like, so you just never know what you're going to see. And so that's why everything, again, is required to have that site investigation so we have an idea of what we're going to design around. So back to the treatment units here. So an aerobic treatment unit also is going to have a treatment chamber as well. So in order to get that 48 inches reduced down to 6 inches, that's where the chlorination or the UV is going to come into play, plus your aeration chamber as well. And so typically when you're driving around here, you see all those 3 green lids. Those are a company that does plastic tanks, and it's the same setup here. It's going to have a trash tank, you have your aeration chamber, and then you're going to have your treatment chamber, and then it's going to go out. A cement one's completely fine as well. They just, when you got a concrete tank, you're going to have a boom truck come out here and drop it off, where those green tanks or plastic tanks, a lot of times you can have that in a flatbed trailer or your truck bed. So that's why a lot of times out here you see the plastic tanks rather than concrete tanks. And again, yeah. No, it's exterior air that's being pumped in. Yeah. Think of it as like an aerator and a fish tank. Nope, you're right. You're right. Yep. Yep. So this aeration, like this little agitator in here, is a moving part. So eventually it would fail. But usually, again, it depends on the use and the abuse of the system. It should last you at least 15 to 20 years. That's what the life expectancy of wastewater systems are. So again, keep in mind that wastewater systems are living systems. You have an environment in the tank, and then you have an environment in your disposal field that eventually is going to be, that soil, pore space is going to be non-existent anymore after 20 years, 30 years down the line. Again, it just depends on the use and abuse of the system on how it lasts. Sometimes systems can last 50 years. Yes, sir. So that's what from the permit that we are going to issue, we estimate a 20-year life expectancy on that. So after the 20 years, again, it's going to be that whole process again, because you can't use that area that's going to be fully saturated. You're going to have to move it over. Eventually, a lot of times it's going to last a lot longer. It's going to be the moving parts. Like out here, this soil is really good. It's going to uptake that wastewater. You just don't have a lot of it, but it is going to accept it for a long time. Especially when you guys are on, hauled water with smaller water usages, it's going to last, plus 20 years. That's another job that you have to do as well. There is a port up top that you're going to drop those tablets into. Your plans that you get, it's going to tell you how many tabs and how many times per month to replace that. Typically what we see a lot of times is they're never replaced again. So we have stronger, sewage going out than what should be. So again, like I live on a wastewater system. Mine's a full pressurized, but I'm a geek about it, so I'm always out there opening lids and checking everything out. And I just want to make sure that it's functioning. We put a lot of money into that, so I want to make sure that it's functioning and working well. So it's something that you got to keep an eye on. You would be able to hear the blower motor working, and then it would just be how many times that you would need to change those chlorine tabs out. These systems. So again, that's what Nina was just saying. They get super pricey. We priced out a couple of these aerobic treatment units. The tank alone was like anywhere from $6,000 to $9,000, and then whatever the disposal field was going to cost you anywhere from $12,000 to $15,000. Materials. But what happens a lot of times is you get those companies from Flagstaff that are coming out here. You're going to charge you those fees to get all their equipment out and all that things like that. And unfortunately, I have no say in that. So those up prices, a system like this that costs you $12,000, sometimes is going to be $40,000 at the end because of all that maintenance and material costs for that company. He had a question here. I'll come right back to you. So that in the state of Arizona is just a one-time thing. They're attempting rule changes right now And one of the things that they want to include is some sort of monitoring on that, where an owner or your operator that you would hire that did the install would come out once a year and test that effluent quality and then would submit it to us. But that is far beyond anything that we're going to be dealing with right now. So right now it's just a one-time thing. I mean, you could, but again, you got to kind of know where you're testing, because you have to compare what's coming out of the house at, household wastewater strength, and then you would have to compare it going out before the disposal field. And again, what you're testing is a total suspended solids, shortened down to TSS, and then your biochemical oxygen demand, shortened down to BOD. So that what that is how much crap is in the water, like for the total suspended solids, and then how much available oxygen for the BOD is available for that wastewater going out. And so those are the parameters that we're testing. So conventional is BOD is 150 milligrams per liter, and TSS is 75 milligrams per liter. So that's typical household sewage. What we're dealing with when those numbers come through these systems, they're dropped down this anywhere from a reduction from 150 to a 30, or a 150 all the way down to a 5. So that's how good these systems are treating the wastewater before it goes out to the disposal field. But again, it's up to the residents to make sure that those chlorine tabs are put in and that everything is functioning. And a lot of these systems aren't running 24 hours a day. Like I said, they're on a timer for that aeration unit. So you're not wasting, all of, your electricity on something when you're not even home during the day or something like that. It's going to kick on X amount of times through a day. Again, yeah, no, it's that's what we're kind of lucky with the state of Arizona is you could design your own system and you can install your own system. But again, all it says in rule is that you do need to be knowledgeable on that. So, it's doable. It's doable, especially a system like with a treatment tank to a leach field. It's not rocket science, but there is a few things that we have to receive and that we have to review that are some calculations. So like I said, that chlorine contact calculation needs to be submitted. And that, again, is specific to the design flow at your house. And then there's other things that come into play, like a buoyancy calculation. I want to make sure that if you pump this tank during a wet season, that it's not going to float. And then a lot of times out here, we have that bedrock, and it creates that bathtub effect. So if you pump your tank out dry and it gets wet somehow in there, it's going to just fill that rock up like a bathtub, and it's going to pop that up out of the ground. So there's not a maximum distance as long as you got gravity on your side, unless you do want to pump it uphill. But there is a minimum setback to your house, which is 10 feet. And that's from any footer or foundation. Any portion of the wastewater system does need to meet that 10-foot setback off of the structure. And I'm going to measure that from the foundation to the footer. So if you had a deck overhanging and I'm going to measure from the pier. That's where that's going to go. And it's kind of a gray area of like the sewer line from the house to the tank is technically the building department. Like that's all that goes under the International Plumbing Code. There's certain falls that you need to make and, certain diameter of the pipe based off of their own sizing. When I go out for final inspection, I'm going to indicate that it's there. I'm going to indicate the material. I'm going to indicate the slope. So when you're dealing with the solids coming from the house to the tank, you want to make sure that you at least have a 1/4 inch per foot fall. And then when you're going from your tank to your disposal field, you could have a much less fall because it's just liquids at that point. And average, I see about a 1/8 inch per foot fall going out to the field. 1/4 inch per foot. Mm-hmm. And that's right out of the IBC. So outhouses are a permit by right, but you do have to make sure that those are vector free and there's no smell, everything like that. So again, when you're dealing with shallower soils out here, you're going to be moving that outhouse quite a bit. But again, that's something that we don't really see very often. But in Arizona, it is allowed. Like if you can build on that lot, you can have it. Yeah, the more information you can give to the designer and how your household uses water and how you use your land, is going to be better for them to come up with a design that's going to be more, pertain to just you rather than their boiler point one that they're going to send out the door. And like Nina said, yeah, these systems here, the smallest you're going to see is for a 3-bedroom house. Like you're going to be at a 450 gallon per day design flow. They don't make anything smaller as of now. So again, you're paying for a tank size that's going to take you a longer time to fill up, which can be good. And then, like I said, it could hinder the system as well. So again, talk to the designers, shop around. There is a resource list that's available on the website of designers and installers in the area. I can't make any recommendations or anything like that, but again, that's there for you folks, and I always recommend shop around. Don't always go for the lowest bid. There's a resource list that's available under the environmental quality page of the community development on the county website. And it's just going to say resource list. It's got excavators, it's got designers, and it has septic installers as well. We kind of briefly touched on this earlier too, is like I'm delegated through the state to review permits, issue permits. And so if it doesn't fall in one of the 21 approved systems through the state, I can't permit it. And where the state's working right now, it's difficult to get these kind of more unique type systems pushed through. Rule change is happening. So again, if you want to see change, talk to your representatives. You got my card. So there's more cards up here, so feel free to take them. And again, if you see me in the neighborhood, say hello. I'm here all the time. So